Alright guys, good morning. Today we're going to be talking about density. This is 8.9 for your notes. This is the last section that we're going to be covering before our review, before our test. So keep that in mind. Make sure that you guys are studying notes. Make sure that you guys are watching videos. Make sure that you are prepared for this coming test. Chances are everything will be on Schoology, so just make sure that you're prepared for all of that. Of course, if you have any questions, make sure that you comment below. Send me an email, whatever you need to do to contact me. Just make sure that you guys are getting the help that you need to make sure that you're prepared to go. So, let's go ahead and get started. Say that we have two cubes that are the same size, like the ones below. One made out of wood, the other of steel. Now, of course, they have the same exact dimensions, so keep that in mind. What do you think would happen if we put them in a swimming pool? Which one would you expect to float, and which one to sink? And then lastly, why? Well, more likely than not, if we put both of these in a swimming pool, one would sink, one would float. The one that would probably sink would be the steel. The one that would probably float would be the wood. The reason why is the density of the object. So, density is a physical property of an object that combines the space that an object takes up, or the volume, as well as the amount of matter present in the object, mass. Now, you guys have probably covered this in your science classes already, and if you haven't, fantastic, you get to cover it now. Mathematically, density is defined as the mass of an object divided by the volume of an object. Now, an easy way to remember this, if I make this little triangle here, this little pyramid, we have density, mass, and volume. Or, mountain point is over desert vista. Nice, easy way to remember this thing. Now, we can also use this equation to find the mass of an object if we know the density and the volume. We can do this just by manipulating the formula by multiplying both sides by volume. If we do that, the volumes will cancel out on the right side, and we'll be left with mass is equal to volume times density. Now we can also see that in this pyramid right over here. Volume is equal to mass divided by density, and density is equal to mass divided by volume, and lastly, mass is equal to density times volume. So if they're both on bottom, we multiply. If one's on top, one's on bottom, it's division. Now again, if you're like, this is a little bit confusing to me, feel free to just manipulate the formulas as much as possible using simple algebra, and you guys will be good to go. So for instance, we have these two formulas. Of course, you can solve for volume here by dividing both sides by density. So just keep that in mind. You can manipulate these formulas as much as you want. Now, back to our problem with the wood and the steel block. The density of wood is 36 pounds per cubic foot, and the density of steel is 490 pounds per cubic foot. Calculate the mass of each of the cubes below. So if we remember, density is equal to mass over volume, then we can know that mass is equal to density times volume. Now we already have the density of the object, and we can find the volume just by using our volume formula for a rectangular prism, which is just length times width times height, or in this case, 2 cubed, which is 8 feet cubed, or 8 cubic feet. So, solving for the density of the wood, I just plug 8 in for volume, and I take the density that they gave us, 36, and I plug that in for density. From there, we can solve for the density of each of these shapes, for each of these objects, each of these materials. So we're going to do the same thing with the steel. And we end up with density of the wood is 288 pounds, because again, feet cubed and feet cubed will cancel each other out. And we just left with the unit of pounds, because this is 36 pounds per cubic foot. Likewise, the steel's mass is 3,920 pounds. So obviously we can tell that the steel's mass is much, much larger than the wood mass. Now, a 288-pound block of wood may seem heavy, but it's nothing in comparison to almost 4,000 pounds block of steel. The block of wood is much less dense than the block of steel. Therefore, if the blocks are the same size, the block of wood should weigh much less than the block of steel. But that leads us to a question. In the world, we have ships made of steel. How do these things float? Well, that leads us back to ancient Greek times. So, The shape of a ship has a lot to deal with it. The shape allows the ship to displace the same weight of water that the ship weighs, allowing the buoyant force to keep the ship floating. So this leads to Archimedes' principle. Archimedes was the father of mathematics, born in Sicily, actually in the city of Syracuse, in Sicily during ancient Greek times. And he went to study in the Library of Alexandria, the famous library in Egypt that burned down, sadly, and had so much knowledge, so many great scholars go through it. Now, after he studied in Alexandria, he returned to Syracuse, and he started studying up more, started devoting his life to his studies and contributing many things to mathematics, such as levers, which you'll learn in Calculus 3 if you go that far in mathematics. A very important concept for us, and it leads to us being able to get more tension out of things. And if you're using a wrench for anything, you're using a lever essentially. He also came up with things such as catapults and hydraulics. He discovered many things with hydraulics as well. And sadly, during Roman conquest of Sicily, back in 214 BC, Archimedes was killed by a Roman soldier. Now, they said that when the Roman soldiers came in, he was just too busy with his work that he told his killer not to disturb him while he was working. But sadly, a great mathematical mind was lost during that time. But he did come up with many great ideas that we still use today. So, Archimedes' principle, one of his most famous contributions to society, basically says that water pushes up with the amount of force of the amount of water you displace. So we're going to see this. We have it right here. Any object that is completely or partially submerged in a liquid at rest, so in this example, we have this 5 kilogram weight, and we submerge it completely inside the water. Now this 5 kilogram weight now drops down to 3 kilograms when it's in the water. Now that's not a coincidence. What happens is that when that 5 kilogram weight was dropped into the water and it's now at rest, the water that was displaced, the water that came out of this little spout here, was 2 kilograms. So 2 kilograms was let out of the actual water. It was displaced. Now that means, by Archimedes' principle, that there's a force now from the water that's pushing up on the weight of 2 kilograms, which makes it go from 5 kilograms on the scale to 3 kilograms. So that force is making the object seem like it weighs less. And that's why when you're in a pool, it feels like you're a little bit lighter. That's because Archimedes' principle is working on your body. It's pushing up on your body with amount of force equal to the amount of water that your body is displacing. Now, due to Archimedes' principle, some great mathematicians, great scientists, great engineers were able to create these new objects, these new ships, that using Archimedes' principle, they now displace a large amount of water. And displacing that large amount of water allows it to push up with a certain amount of force, which will keep those ships afloat. So that's where Archimedes' principle comes in now. So, moving on to population density. So we just finished talking about density in general. Now we're moving on to population density, which is going to be the focus of your homework. You will see some stuff with this on the test as well, so keep that in mind. Population density is a measurement of population, or the number of items per unit area. So again, we're going to be dealing with units squared in this case, so our area will be in units squared. And then we'll have the population up top. Now, it's frequently applied to living organisms, specifically humans and livestock, but we use it for multiple other things as well, such as knowing how much pollen's in a certain area, knowing how much pollution's in an area, all these different things. But it has very many useful reasons to use it. So, looking at this, we have the population per square mile by state from 2000 census figures. Now, I looked at an updated version of 2013. There was not really much change from this population density image, except like maybe Utah was a little bit less than it is currently, but you notice that not much has changed. So I just kept with the original image, and as we can see, we have the population per square mile by state. So if the population per square mile is anywhere between 0 to 20 people per square mile, it's going to be this light color, like we see in New Mexico, Nevada, Idaho, places like that. As we increase, as the color gets darker and darker, there's more people per square mile. So if we look at California, for instance, it's much darker, so that's probably around 200 to 500 people per square mile, which is a large amount of people. If we look at the East Coast, many states on the East Coast are very heavily populated, population density-wise. And the reason for that is when the country was founded, it was founded on the East Coast, and then people spread west over time. So people didn't automatically just spread to the west. It took time, and as a result, people are still expanding out into the west area. Now, along with that, there's a lot of farmland in here in the Great Plains, so there's a lot more open space for people as well. So population density allows us to kind of know where people are at, know where they're physically occupying, and know how many people are in those areas per unit of measurement. And typically it'll be miles squared, such as in this image here. So we are now going to be finding the population density of our state, Arizona, by county. So we have 15 counties in Arizona. We're going to go ahead and determine the most heavily populated areas and also the most rural areas, the least populated areas, least populated density areas, I should say. So in your notes, you're going to go ahead and copy down the table on the next slide, the population density of Arizona counties. That's how you can title it. And then you're going to be finding the most populous dense county in Arizona and also the least. Think about why this information can be important as you work through it. So go ahead and take a minute, copy down this table. You can pause the video if you need to, and we'll be talking about this in just a minute. All right, so looking at this, the population for each county, I organized this table by the most heavily populated areas, and I went down and it got less and less populated. And then I just found the area per mile squared for each county as well and just labeled it out. What you guys will be doing is finding the population density, and hopefully you use the equation. Population density is equal to population over miles squared. And you were able to find the population of each area. Now you'll notice the more heavily populated areas are often the more population dense areas. However, that's not always the case, and we see that in Arizona as well. So looking at this, Maricopa County has 461.1 people per square mile. Pima, 111 people per square mile. Pinal County is 78.1. Yavapai, 27.6. Yuma, 37.7, so on and so forth. Now we can tell right here that Yuma County is much more, well, not much more, but more heavily populated per square mile than Yavapai County. So it doesn't always follow the population trend. It does jump around a little bit, and we can see that with Santa Cruz as well. Santa Cruz is just 0.1 of a person, which doesn't really make sense as a statistic, but it's just very, very slightly less than Yuma County. So, and yet it has 150,000 less people in it. So, as we can see, population and population density don't always map up. Now, some reasons for this, why this is important. Right now we're dealing with this virus that's going around, and in some of these counties, such as where I'm from, Gila County, we see that there's a lot less people per square mile. Now that makes social distancing a little bit easier, but also on top of that, you have an idea of where supplies are going, how many supplies need to go to these areas, and how many people you need to supply for. This also goes towards knowing how many people are congested in a certain area, and it deals with pollution, light pollution and air pollution, things like of that nature, water pollution. You'll notice that there's different trends with more populated areas, such as Maricopa County, where we're located right now, and less population dense areas, such as Coconino County or Apache County, things like that. Now, if we rank all these out, we see that, of course, it kind of matches our trend of population, but Maricopa County would be the most population dense area. Pima second, Pinal third, Yuma fourth, Santa Cruz fifth, and so on and so forth. So the most heavily population dense area is Maricopa, the least is La Paz County. Now there's some reasons for this. For instance, where I'm from Payson. It's in Gila County, where it's 11.1 people per square mile. Payson can't really grow that much, and the reason for that is because it's surrounded by the Tano National Forest. The Tano National Forest is federally owned land where you can't actually build upon that unless you are able to get the land sold by the government, and then from there you got to go through a very long process of being able to build upon that land. So Gila County is very limited in how much it can grow right now, and I shouldn't say that. Payson is very limited in how much it can grow right now, and Payson is one of the larger towns in that area. The county capital, I guess you could call it, for Gila County is Globe, Arizona, but Payson is a pretty large town for that county. So there's a reason why the population isn't going to grow that much in Gila County. In Coconino County, for instance, where Flagstaff is located, there's 7.5 people per mile squared. Now, they also have many laws in Coconino County where, for instance, their light pollution, they try and keep it very minimal because there's an observatory there, and they want to make sure that they can actually see the stars, and that way they can observe the universe. But if there's a lot of light pollution like we see in Maricopa County, for instance, seeing the stars is much more difficult for us to do. And as a result, most of the time you're just able to see satellites flying around unless you actually go out and go to an area where there's not much light pollution at night. So many different aspects to these types of things. And then of course, I made sure that I ranked all of them so that we can see the heaviest population density area and the least as well. Now, we can also do this with animals. So go ahead and look at this graph for a minute. We can see it's the population density by county. So these are all little counties within the U.S. based on inventory at the time of the 2007 census. So this is a little bit dated material as well, but it gives us a good idea of where the animals are at in the United States, where our livestock are. So, as you can see, cows are pink and they're all over the place. Pigs are yellow and they're more heavily located kind of in the Midwest here, and a little bit on the East Coast. Sheep and goats, those are the light blue, kind of the teal color. You can find, I guess it's more teal. You can find those in Texas, little pockets here and there. I'm not sure if this would actually be chickens or sheep and goats. I know that this would probably be sheep and goats, seeing I've seen some of them in that area before as well. And then, of course, the darker purple, the darker blue looking color is all the chickens. And then lastly, we see turkeys up in the Midwest as well as on the East Coast as well for their population dense. And we can see that they're very populous over on this area as well. Now, from here, why could the areas of livestock and their population density be important information to the general populace? So, these things are important for us because we want to know how these animals are living, because it's what we put into our bodies. It's also good to know how far these animals have to travel to get to our supermarkets where we buy our food. And if you're looking at emissions of CO2 levels based upon animals, that information would be useful to actually compare and contrast how much emissions these animals have compared to different things such as vehicles and what we're driving around. So it leads to us knowing more about these environmental issues that could be occurring as well down the road. What could be reasons for areas that are in white? Why are there more pigs in the Midwest, chickens in the Southeast, that should be east here, and cows in the Great Plains? So, if we think about this, these areas that are in white, we see some of these in Arizona and Nevada. Well, if we think about Nevada and Arizona, it's very heavily desert area, desert landscape. And cows oftentimes need grasslands in order to feed so that they can just go from bush to bush, essentially, grass to grass, and graze and get their nutrients, get their food. If you're in the middle of a desert, there's a bit less that you can actually eat if you're a cow, so that's more likely the reason why these are in white. Same thing goes for chickens, stuff like that. But that's what these white areas will typically represent. Maybe some mountainous areas where it's very hard to have pasture lands, stuff like that. But that could be an explanation for these areas of white. Now, is that the end-all be-all reason for them? Not necessarily, but that is one reason why those could be there. As for the pigs in the Midwest, chickens in the Southeast, and cows in the Great Plains. Well, let's start off with cows. Cows in the Great Plains, well, again, we just talked about pasture lands. Pasture lands where the cows can graze and eat their grass throughout the day. Well, that's mostly common in flat areas with a lot of nutrients in the soil, which is found in the Great Plains of the U.S. And that's why cows are very heavily populated in these areas, and that's why it's darker pink in here as well. So that's one reason why they're all in those areas. Meanwhile, chickens in the Southeast, well, one interpretation of this could be it's more humid in the Southeast than other parts of the country. I mean, granted, it is humid in the Great Plains as well, but in the Southeast, it's very, very humid. And that means that more bugs will populate those areas. And if you have more bugs in these areas, then oftentimes the chickens will be eating the bugs and enjoying those meals, so that's why they'd probably more heavily populate those areas. That's not to say that there's no chickens in Arizona, but in terms of large amounts of these animals per square mile, there's much more of them in the south than in, for instance, the west side of the country. And then lastly, as for pigs in the Midwest, reasons why it could be many pigs in the Midwest is the natural lifestyle that the pigs would like to live in, their natural, well, not natural environment per se, but a healthy environment for them to live. It could be dealing with when immigrants came to America that were farmers. They brought what they knew and what they enjoyed to eat, and that could have been pigs. But many different things, immigration patterns could play into these as well, and also just supply and demand and just good habitat for the animals to live. It could be that there's many truffles in these areas as well, something that pigs sniff out, and so people are interested in getting those truffles because they sell for high dollars, and so they could have pigs in those areas as well just to try and get to those truffles. So lots of different reasons, lots of different ways that you can go about thinking about these things, but those are just a couple of them. And of course, if you have any of your own that you thought of, you can go ahead and comment on those down below and just think about different ways that you can do that. So let's go ahead and try this problem out. Go ahead and take a minute, try this out on your own if you'd like, and then we'll be going through it together as well. All right, so the population of Florida in 2010 was 18,801,310. The land area was 53,625 square miles. The population increased by 5.8% by 2014. To the nearest whole number, what is the population density in people per square mile for Florida in 2014? So we're going to need to do a little bit of multiplication here. If I want to find out the population density in Florida in 2014, first I need to find the population of Florida in 2014. So I take our population in 2010, 18,801,310, and I multiply it by 5.8%. Now I need to switch this to a decimal, so I move my decimal place 2 places to the left, giving us 0.058. Now if I multiply these two numbers, I'm going to get a very, very, very small number compared to 18 million. But I don't want that. We know that we're growing because we're increasing in population. So I'm going to put a 1 in front of that decimal. And that's saying we're starting at 100% because if I multiply 1 by anything, it won't change. And if I multiply by a little bit bigger than 1, this 0.058, much more than 1, it's saying that we're increasing by 0.58%. Now, you may remember this with exponential functions from last year. This is the same type of concept in getting it from percent to decimals and multiplying it through. So if we do this, we go ahead and we get our population of Florida in 2014 being a little bit above 19 million. And from there, we go ahead and we use our population density formula, which is population density is equal to the population divided by our area in square miles. Well, of course, as we can see, we get 19,891,786 people in 2014. If I divide that by our square mileage, we end up with 371 people per mile squared. So that's how many people per mile squared are in Florida in 2014. If I want to see how much growth the population density occurred in Florida per square mile from this time frame, 2010 to 2014, I first need to find the population density in 2010. Now we can do that easily with the numbers that they already gave us by go ahead and divide 18,801,310 by 53,625 miles squared. This will give us our population density in 2010, which of course is 351 people per mile squared. If I want to find that difference, I just go ahead and I subtract those two population densities. So 371 people per mile squared minus 351 people per mile squared gives us a 20-person difference per mile squared in Florida during those 4 years. That means that there's 20 people that move to Florida for every square mile of land that Florida has, which is quite a bit of people. So keep that in mind. That's how we can track how many people per mile squared has occurred. If you think about it in terms of the Phoenix area, well, that's saying that, well, we know each major road is about a mile squared, so each block is a mile squared for us. That's 20 people moving in over 4 years without anyone moving out in those areas. So it is an increase in people, and that's how we can kind of track where people are going, where these heavily populated areas are, and people will use it in many, many different aspects. So this is what population density allows us to use. Now, let's go ahead and talk about population density in terms of pollen count. So pollen count is the measurement of number of grains of pollen in a cubic meter of air. The higher the number, the more people will suffer if they are allergic to a particular pollen, which is hay fever. So for instance, I was at a plant nursery. My dad works at a plant nursery. And what they do is, if you go around citrus trees this time of year, citrus trees are in full bloom. They're getting lots of pollen from these different bugs that are pollinating them, such as honeybees, butterflies, all these different things. And walking by them, I automatically start choking up a little bit because I am very sensitive to pollen. So the way that they measure these pollen counts is they take a rod, such as this rod right here, and they grease it. They cover it in grease. So that's the grease along our rod. Now, they'll take this rod and they'll spin it around periodically throughout a 24-hour day. And as they spin it around, all these pollen particles that are in the air start getting stuck on this grease. Now, after the 24 hours, they then remove this rod, they bring it to the lab, and they determine what type of pollen is in the air. And they do that using different tools and different scientific methods in order to find out where this pollen is, what type of pollen it is, and how much is concentrated. This allows us to warn people of, hey, you might want to stay out of this area, or there's a lot of pollen in this wheat field right now because everything's in bloom. Take precautions when you go in and work there, or wear a face mask when you're working in there. Things of that nature. So that's what we can use these different tools for, and that helps farmers out who are working the land quite a bit, knowing, okay, there's going to be a lot of pollen today, or a lot of pollen over this next week. I need to make sure that I'm prepared myself to go out into that. Lastly, pollution. Pollution is also very highly used in these types of ways. People are able to track the pollution within different areas. For instance, in the Maricopa County area, there's typically pretty high pollution just because we are in a city environment, and cities oftentimes have many people driving. A lot of pollution goes into the air, and so there's high pollution advisories. They track these through different scientific methods as well and determine how much pollution is in the air and whether it's safe for people to go out. So oftentimes I get these emails as well where it says that it's a high pollution advisory, try and reduce driving, so ride the bus, ride the light rail, carpool, make sure that you work from home, stuff like that. Combine trips, don't go out multiple times, don't go out to the grocery store and then come home, and then don't go out to the restaurant next, do it all in one trip if you need to. Refuel after dark, limit engine idling, so try not to stay in heavy traffic and just wait, or don't use gas-powered garden equipment or charcoal barbecue such as like leaf blowers and stuff like that. And it lets people know that if they have like asthma or something, that it's dangerous to go outside. Your asthma may have a kick up, a flare up, if you're going outside during high pollution advisories because there's so much pollution in the air. Now, for instance, if you go to northern Arizona, Coconino County, where Flagstaff's located, Gila County, where Payson's located, these different towns, these smaller areas that are less population dense, then oftentimes the air is a bit cleaner for people to breathe in because they aren't having all that pollution brought into the air. Now, that's not to say that there's no pollution there. It's just less pollution. So these high pollution advisories, they are important for a lot of people, and a lot of people that are at risk of these types of things, it's important for them to know whether they can be out exercising throughout the day or whether the pollution is just bad today and we should stay indoors and close up the windows, things such as that. So that's all I have for you guys today on density. Your homework tonight is going to be in Schoology. Just complete the assignment by tomorrow at midnight. I'll be grading it then. If it's not done by then, of course, it'll go in as missing until you turn it in for me. But try and get it done as soon as you guys can, get that extra practice in. The test will be incoming soon. I'll let you guys know of the exact time frame that you guys will have. You guys will have a time limit on the test of an hour, just like in class. It will be computer based, and just make sure that you guys are preparing for that yourselves, and make sure that you're in the right mindset for going through these. If you guys need to, review the videos, review the notes, do the homeworks, get the extra practice in, but it will be available for you guys soon, so do your best on that test. It's not going to change anything such as from when we were in school. It's going to be the same exact procedure for you guys. Just make sure that you guys do your best, and of course, if you have any questions, please let me know. The test will be on Schoology, unless we get back into school before then, but as of right now, that's not looking likely, so just make sure that you guys are preparing yourselves that you will probably have this test online. If you guys have any questions for me, just let me know. You could either leave comments down below, you could also send me an email, whatever works best for you. Other than that, guys, stay safe, have fun. I'll see you soon. Thanks.